Today we are going to learn conditional statements and loops from absolute basics. First, let us understand what a program actually does. A program is simply a set of instructions given to the computer. Sometimes the computer must make decisions, and sometimes it must repeat the same work again and again. To handle decisions, we use conditional statements. To handle repetition, we use loops. Let us start with conditional statements. In real life, we make decisions every day. If it is raining, we take an umbrella. If the signal is red, we stop. In programming also, we want the computer to take decisions like this. Decisions are made using conditions. A condition is something that always gives only two results, true or false. The first conditional statement is the if statement. The if statement checks a condition. If the condition is true, the code inside the if block will execute. If the condition is false, the code inside the if block will be skipped. For example, if we check whether a person's age is greater than or equal to 18, and if it is true, the program will say that the person is eligible to vote. If the condition is false, nothing happens. Sometimes we want the program to do something when the condition is true, and do something else when the condition is false. For this, we use if-else. In if-else, if the condition is true, the if block executes. If the condition is false, the else block executes. For example, if a student's marks are greater than or equal to 35, the student passes. Otherwise, the student fails.
Let's look at the small example for if and if else. So we are going to check whether it is even or not. If even, we are going to return true. If not, we are going to return false. So the condition is if n divided by 2 is equals to 0, then it is even. So we are going to return true. If not, we are going to use else. So that is the use of else. Else, it is odd. So we are going to return false. Let us check. Yeah. So if you look at here, this is if else. If we remove this, this is just if condition. That means only one will be executed.
Now, what if we have more than two conditions? For example, grading a student as A, B, C, or fail. In such cases, we use if-else if-else. The program checks conditions from top to bottom. As soon as it finds a true condition, it executes that
block and skips the rest.
We are going to check greatest among three numbers. So the condition follows as if A greater than or equals to B and A greater than or equals to C, then A is the greatest one. Else if B greater than or equals to A and B greater than or equals to C, then we are going to return B. Else if both are false, then we are going to return C. This is the simple example for else if ladder. Let's check. We are done.
Now let us understand the nested if condition. Nested if means placing one if condition inside another if condition. It is used when one decision depends on another decision. First, the outer if condition is checked. If it is true, then the inner if condition is checked. If the outer condition is false, the inner condition is skipped. For example, first we check whether a student is present. Only if the student is present, we check the marks. If the student is absent, we do not check the marks.
So let's look at example for nested if. So we are going to check whether it is leap year or not. So if n divided by 4 equals to 0 and if n divided by 100 equals to 0 and also if n divided by 400 is equals to 0, then only we are going to return true. That means we are going to write conditions, one if inside other if. Else for the third if condition, if it is false, then we are going to return false. Next, if only first two conditions are true, then we are going to return true because If both the two satisfies, then it is also called leap year. If the first condition itself is false, then we are going to return false. Let's check.
Next, let us understand the switch statement. The switch statement checks the value of a variable and matches it with different cases. When a match is found, that block executes. The break statement is used to stop execution after a case.
Now let's take a look at switch case example. So we are going to take the operation as 1. We are going to add two numbers. So for passing to switch, we took operation and initialized as 1. So switch operation if case 1, if that means the operation is initialized with 1. So the case 1 is true. So it will return num1 plus num2. Default we are returning 0. So now let's check it.
Now let us focus only on loops. Loops are used to repeat a block of instructions multiple times. Instead of writing the same instructions again and again, we use loops to make our work easier and cleaner. There are three main types of loops. They are for loop, while loop, do while loop. First, let us talk about the for loop. The for loop is used when we already know how many times the loop should run. It is commonly used for counting, such as printing numbers from 1 to 10. The for loop has three important parts. The first part is initialization. This is where we set the starting value of the loop variable. The second part is the condition. This condition is checked before every iteration. If the condition is true, the loop continues. If the condition becomes false, the loop stops. The third part is increment or decrement. This updates the loop variable after each iteration. For example, if we want to print numbers from 1 to 5, we start with a value of 1. Check whether it is less than or equal to 5. Print the value, increase it by 1, and repeat the process until the condition becomes false.
Now using for loop, let's print 1 to 5 numbers. So taking n as 5. Next, for int I is equals to 0, I is equals to 1, starting from 1, right? So I less than or equals to n, I plus plus. We are going to print the I value. I is equals to 1 means initialization, next condition, next increment or decrement. Now let's check it. You're done.
Next, let us understand the while loop. The while loop is used when we do not know in advance how many times the loop will run. The loop keeps executing as long as the condition remains true. In a while loop, the condition is checked before the loop body executes. If the condition is false at the beginning, the loop will not execute even once. For example, to print numbers from 1 to 5, we first set a value to 1. Check the condition. Print the value if the condition is true. Increase the value, and repeat this process. If the value is never updated, the loop will keep running forever. This is called an infinite loop.
Now let's take a look at the while loop. So same 1 to 5 numbers. First n is equals to 5, that means 5 numbers we need starting from 1. So that is I. While I less than or equals to 1, that is the condition. That means 1 less than or equals to 5. Yes, again we are going to print I and we are going to increment the I. Until the condition is false, that will be executed.
Now let us learn about the do-while loop. The do-while loop is similar to the while loop, but there is one important difference. In a do-while loop, the loop body executes at least once, even if the condition is false. This happens because the condition is checked after the loop body executes. For example, even if a condition is false at the start, the instructions inside the do-while loop will run once and then stop. This loop is useful when we want the instructions to run at least one time, such as showing a menu or taking input once before checking a condition.
Now let's take a look at do while loop. It's similar to while loop, but we are going to print the I value before checking the condition only. That means I is equals to 1 and I is get incremented. After that we are going to check the condition. That means one time it will be executed. So we'll get the same result. The numbers are printed from 1 to 5. So now let's check it. So done.
To summarize, use the for loop when the number of repetitions is known. Use the while loop when the number of repetitions is not known. Use the do while loop when the loop must execute at least once. Loops are a very important concept because they reduce repetition, save time, and make programs more efficient.